All right, so we're going to look at testing this claim. And so the claim that we're making is that the population mean is 40. So because it has an equal sign, that's going to represent our null hypothesis. And so mu equals 40. That means our alternative hypothesis, mu does not equal 40. And so we want to test this claim. So what we're going to do, because it's an equal sign, it's going to be a two-tailed test. And our significance level is going to be an alpha of 0.08. So what we're going to have in here is each side is going to get half of that, 0.04. And so what we want to do when we go to test this, what we want to be able to pull out of here is where our critical points are as a z value, and how to test this in general. So let me switch over to our calculator here and work on a way of getting our standardized test statistics out of this. So first, we're going to use a test statistic. So we're going to come into test and we're going to use a z-test. And we're going to do it by stats. And so we're going to use 40 as our population mean. Our standard deviation was 3.35 from the problem. Our x bar was 38.3. And we had 74. And the calculation we're doing is on the alternative test, mu naught. So we're going to calculate. And so it comes back out, we get our z-score, we get our p-value, and we get a repeat of our x value. So we want to take this z-score and bring it across, because that's the critical value that we're going to look in, or the standardized test statistic, which is z is minus 4.36. So what it's saying, if I come back here, let me see, up, there we go, back to the blackboard, that the z from these statistics, using our, is negative 4, calculator back up here, 0.37. And so somewhere in here is our z statistic, if we know what this critical boundary region is. Now to find our critical boundary, we have to notice that, hey, this is a part of a normal curve, and we need to find what the critical value here for. So z critical, again, we're going to use our calculator to do this for us and find our critical value. So let me get back to my calculator here. Bring this back up. And what we're going to do is we're going to use a distribution. So I'm going to hit second in distribution, and we're going to want the inverse of a normal. And we're looking for an area of 0.04. And that's with a mu of 0, because this is normalized, mu of 0, and a standard deviation of 1. So we'll paste that in. And that tells us that our lower critical value is negative 1.75. And because this is symmetric, our upper critical value is positive 1.75. So we can bring that back over here, and we can say that our critical values are plus or minus 1.75. And so that means this line is at negative 1.75. And so this falls in our rejection region. So we have to reject the null hypothesis. And so the evidence does not support the null hypothesis, which happens to be our claim. So there's not enough evidence to support our claim. And so here we can use our calculator to help us test our statistics and get us through this problem by having it find the regions that are important to us. We could have, if we go back on our calculator here, And look, when we did the tests, let me see if I can get back to it. Oops. Go to stat, tests, and the z-test. And our data is still there, so we'll come down to calculate. If we look at our p-value, this is 1.27 times 10 to the negative fifth. This is less than our alpha value. And so we know we're in the rejection region again. So we could have done it by comparing the p-value to our alpha, or we could do it comparing the critical point like we did. But both are valid in helping us reject the null hypothesis.